Hi, my name is Andrew Larsen, and I've put together an analytic report for Frito-Lay for analysis of talent management using existing employee data. This data was given to us by Frito-Lay in the dataset case study 2-data.csv. There are no NA values. There are 9 factor variables and 27 integer variables. We are trying to predict one of the factor variables using classification and one of the integer variables using regression. The classification variable that we are predicting is attrition, and it is unbalanced, meaning that there are more no's than yeses. In order to combat this, we made a test train split of 80%, but the 80% is the amount of yeses in the training data set, and we have an equal amount of no's in that training data set. So really the test set is the one that's unbalanced, and our trained data set is unbalanced. We do use this 80% split for all of our classification models. In our regression model, we just split the data evenly. In order to gauge how well each of our models did, we use accuracy, sensitivity, and specificity. Accuracy is how many correct predictions the model made out of how many total predictions that the model made. Sensitivity is the true positive rate, which means that given that someone is a yes, what is the probability that the model predicted yes? Specificity is sensitivity, but for no. We want to maximize accuracy and sensitivity more than specificity because we want to have a more accurate prediction if someone's going to leave. It's more important that we get the yeses right than the nos right. So we did an EDA. We studied the relationships gender versus monthly rate, education versus monthly rate, gender versus years with current manager, work-life balance versus monthly rate, and marital status and gender versus job satisfaction. So to the right, you can see gender versus monthly rate, and they are very, very similar. In fact, females have a higher average monthly rate than males, which is not common at many companies. All of these relationships were pretty close to each other. Gender didn't really affect monthly rate, education really didn't affect monthly rate, and so on. This shows to me that Frito-Lay has done a great job at making sure that both males and females enjoy their current manager, have good job satisfaction, have a similar monthly rate. It's not very common at different companies, so it's great to see that at Frito-Lay. We also looked at interactions for attrition. So to the right, you can see an extreme version of the interactions that we saw. On the x-axis, you can see the department, and on the y-axis, you can see the age. People who are younger have a higher attrition rate than people that are older. That makes sense. But human resources specifically have a higher attrition rate for young people than old people. We also looked at job role and age, marital status and age, business travel and monthly income, and education field and monthly income. All 5 of these interactions ended up being put into the initial logistic regression model. So moving on, we started to predict attrition using a KNN model. We started with all of the numeric variables in this KNN model because you can't put categorical variables into a KNN model without one-hot encoding, and I didn't think that that was appropriate for this analysis. We did 50 iterations each of 30 Ks, and we found that K equals 50 and it maximizes accuracy, but accuracy only maxed at 57.4, which just wasn't high enough for this model. We moved on to naive Bayes, and we put all of the categorical variables into this naive Bayes classifier instead of the numeric variables, and we found that the accuracy went up significantly. For 50 iterations, the average accuracy was 69.2, the average sensitivity was 69.3, and the average specificity was 67.7. This is significantly better than our initial KNN model, but we wanted to make sure that we were providing the best model for you, so we tested 2 more. One of those was the LDA model. We added all categorical and all numeric variables into this model. We did 50 iterations with the average accuracy of 66.4, an average sensitivity of 68.1, and an average specificity of 66.3. This did better than the KNN, but worse than naive Bayes, which leads me to believe that the categorical variables are important for predicting attrition, but the numeric variables, not so much. Moving on to our final model, the logistic regression model. We put all categorical and numeric variables in there, plus the interactions. This was a lot of variables, so we did a feature selection we did backwards selection specifically, and we did 50 iterations of that and classified anything greater than 43% as a yes. We found that the average accuracy was 68.5, average sensitivity was 72.7, and the average specificity was 68.3. Sensitivity is higher than specificity here because we said that anything greater than a 43% is classified as yes. I highlighted the importance of sensitivity earlier in this presentation. Our highest average sensitivity was this model, and it only has 0.7% less accuracy than our naive Bayes model. This was our best model for predicting attrition, in my opinion. So this model was used to predict attrition in the case study 2 CompSet no attrition CSV file. And we also use this model to find the most important factors in determining attrition. These were if someone works overtime, job satisfaction, and job role, with manager and manufacturing director less likely to leave and sales representative more likely to leave. Moving on to salary prediction, we used a linear regression model. We use the variables age, percent salary hike, job level, and total working years and years at company. These were determined by a combination of backward selection and our initial EDA. We did 100 iterations of this model, and we found that the average root mean squared error was 1050, which is significantly less than the $3,000 maximum root mean squared error that was allowed. In conclusion, our logistic regression model was used to predict attrition with an average accuracy of 68.5, an average sensitivity of 72.7, and an average specificity of 68.3. Our linear regression model was used to predict salary with a root mean squared error of $1,050. Salary, years with current manager, job satisfaction were not affected by gender, which is not always the case at all companies, but Frito-Lay, good job on that. And the most important factors for turnover were if someone works overtime, job satisfaction, and job role. Thank you for coming to this presentation, and I hope you have a great rest of your day.